let's move on. 1I, a sequence defined by a naught is equal to 2, and then for n greater than equal to 1, an is 1 more than the product of all previous terms. Okay, so a1 is 3 and a2 is 7, for example, fine. It follows that for all n greater than equal to 1, you have, some expression for an, or even none of the above. We hate these none of the above things, right? Because, we can't really guess it then. Okay, so let's have a look. The first sensible thing to do is to try to eliminate the silly answers, right? So I would try to substitute, and from me looking at this, if you sort of substitute the numbers in, it sort of all works, right? Until a2, it sort of all works. So maybe let's try a3. What's a3? a3 is 7 times 3 times 2 plus 1, which is 43, is it? Yes, 43. Okay, well, let's try then. Well, is a correct then? 43 equals to 28 minus 5? Because a2 was 7, right? So a is definitely wrong, right? 43 is not 28 minus 5. How about b? 43 equals 7 times 6. Sorry, I got ahead of myself. This should be 7. So 7 times 7 minus 1 is 7 times 6, which is 42, plus 1. Okay, b sounds okay so far. How about c? You sub in 14 times 4. That's way too big. Okay, so bye. And then how about this one? When n is 3, do I get anything? No, that's way too small, I think, right? 27 over 2 minus 3 over 2 plus 2. Yeah, that's way too small. Okay, so d is no good. So now I'm left with b and e already, right? Already down to 50-50, yeah? Okay, now question becomes, well, is b the correct answer, or it's just a fluke, right? Now, technically, you could keep on checking a4, a5, and so on, right? But then the problem is, what if the mistake comes when it's a 1,000? Then you're going to have to try 1,000 times before you get there, which is not very good. All right, so instead, let's try to use some logic to get through this. All right, let's convince ourselves that b is indeed the correct approach. Okay. So first of all, let's think about this chunk. What is an minus 1 minus 1? What's inside the brackets? Well, remember, an minus 1 up here is also 1 more than the product of all previous terms, right? So this would be an minus 2, an minus 3, times until a0, right? Timesing all of them, just like how the factorial works somehow. Yeah. And now you're adding an minus 1 in front. So what is this? This is the product of all previous terms, but for an, right? And you add 1 behind, which is exactly the definition we want. Yeah, it's the exact definition that we want. So this is a very nice recursive definition of the sequence. Yeah, so b is indeed correct.